What if you could monitor how much shrubland and grassland vegetation is growing right now anywhere in the lower 48 states of the US without stepping foot in the field? With near real-time vegetation production reports from Climate Engine, we can acquire decades of advanced insights on forage conditions for any location in the country using satellite data. Whether you're managing grazing allotments, overseeing land stewardship, or tracking drought recovery and response, these tools deliver actionable science-based insights at your fingertips. Monitoring large landscapes like grasslands and shrublands across the western US has always been a major challenge. It's simply not practical or scalable to physically survey thousands of acres every few weeks. Traditional field monitoring methods provide vital data for remote sensing models, but they are too labor-intensive and time-consuming for broad-scale assessments. That's where satellite-based vegetation production data comes in. These datasets give us frequent, consistent, and spatially complete estimates of how much and what types of vegetation are growing across the land. Whether you're making grazing management decisions, monitoring the effects of drought, or tracking post-fire recovery, you need more than just a snapshot in time. You need reliable information on current conditions, trends, and comparisons to normal conditions that are updated regularly, not just once a season or at the end of the year. These remote sensing data sets deliver exactly that. They deliver near real-time data over expansive areas so that grazing specialists, resource managers, and other practitioners can compile data quickly for efficient decision-making. These reports provide validated and consistent data simply by drawing a shape on a map and clicking Generate Report, and can be used alongside additional evidence like field data. So before diving into the two case studies, let's understand the two key datasets used in the reports. The first is the Rangeland Analysis Platform, or RAP for short, a dataset developed by the USDA Agricultural Research Service in collaboration with other partners. The RAP vegetation production dataset uses satellite imagery to estimate how much herbaceous vegetation, that's grasses and forbs, is being produced on the landscape. These estimates are provided every 16 days at a 30-meter resolution with near real-time updates. This time series goes all the way back to 1986, which makes it one of the longest and most consistent records of vegetation production available anywhere. In these Climate Engine reports, each 16-day production value is compared to the 20-year historical average preceding the reports. So for a report produced in 2025, the time period from 2005 to 2024 is used. This allows you to quickly see how current conditions compare to long-term normals. RAP's long-term historical record makes it incredibly useful for assessing seasonal anomalies, year-to-year variability, and long-term trends. RAP provides the ecological context you need, updated roughly twice a month. For more information on the Rangeland Analysis Platform datasets, visit support.rangelands.app or rangelands.app. We also have more information at support.climateengine.org. Next up is GridMET, a daily climate dataset developed by researchers at University of California in Merced. In the vegetation production reports, we specifically use GridMET's precipitation data, which provides daily estimates at a 4-kilometer resolution, a coarser grid than RAP, but still high enough to capture important local variation in rainfall. To make the data easier to interpret in the reports, precipitation is summarized into 5-day periods. This lets us see not just how much rain has fallen, but when, which is crucial for understanding rainfall events aligning with vegetation growth and drought stress. GridMET is available from 1979 to present and summarized for the same 20-year period as RAP in the reports. For more information on GridMET, visit support.climateengine.org. Now that we have an understanding of the types of data presented in the vegetation production reports, we can explore the reports more in detail. This report was generated using RAP production data that is current through August 12, 2025. So all data provided throughout this report is provided through that date. On the top left column, we can see the year-to-date production maps from January 1st to August 12, 2025 as displayed. On the left, you'll see the annual forbs and grasses, or AFG map. The maps display production in pounds per acre. Production is uniformly low across this unit, mostly pale tones, indicating very little annual growth of AFG so far this year. To the right of that is perennial forbs and grasses, or PFG. Here, production is much stronger with clear gradients. Most areas display a production between 400 to 600 pounds per acre or more. The greener pockets may reflect areas with more favorable soils, moisture, or exposure supporting perennial herbaceous biomass. Beneath those are the anomaly maps, which display the percent of average relative growth to the recent 20-year baseline from 2005 to 2024. Notice that AFG shows widespread negative anomalies. An important caveat to note is that when the total production for a given vegetation type is very low, the anomaly percentages can be misleading. A small absolute change will look like a large percent difference due to small denominators. So interpret low production anomalies with caution. PFG anomalies, by contrast, hover near neutral to slightly positive overall, which is consistent with what we just saw in the production map above. At the bottom, the heat maps show 16-day production for AFG and PFG from 1986 to the present, with each row representing a year and colors showing intensity of production during each 16-day interval. The legend shows the production in pounds per acre. In the PFG panel, we see consistent seasonal pulses from late spring into summer. But over time, especially from June to August, the heat map shifts from darker blues in the late 1980s and 1990s to lighter greens in the more recent decades. This indicates a long-term decline in summer perennial production, even though the current year looks slightly above average relative to its 20-year baseline. The AFG panel, by contrast, shows consistently low production with many years of sparse growth. In this location, annuals simply do not contribute much to the overall production, with perennial plants dominating. Again, this is a good indication to take care when interpreting anomalies when production totals are very low. In the Vista Plains allotment, the chart of the current year production rate compared with historical percentiles shows how 2025 is unfolding compared to percentiles during the past 20-year baseline from 2005 to 2024. The black line traces the total production of annual and perennial forbs and grasses across the growing season. In the first half of May, the total production for the current year is below average at around the 30th percentile of historical production. However, by the end of May and June and until August, the black line climbs into the 60th to 80th percentile band, showing that forage growth is running above average or the median of total production. This figure provides an indication of timing of production during the current year when compared to the distribution of previous years. Now below we can see the year-to-date cumulative production and precipitation summary, which gives us a more detailed breakdown by vegetation type and provides climate context. In the top panel for annual forbs and grasses, the black line for 2025 sits well below the mean, and it trails quite close to the median. This indicates that production from annual forbs and grasses is below average for this year, though again, production from annuals has always been quite low for this unit. In the middle panel, for perennial forbs and grasses, the 2025 line begins below the mean and median line until late June, but then rises above the mean and the median, showing that perennials are more productive than the 20-year average. This tells us that the overall productivity of Vista Plains this year is being carried out almost entirely by perennial grasses. The bottom panel adds precipitation to the picture, and here the story comes into focus. The cumulative precipitation line for 2025 is below the historical average nearly the entire year, reflecting the fact that the allotment has been drier than normal. However, notice that precipitation increased sharply in early June, immediately before the uptick in production. Even with below average precipitation, perennials maintained above average production, which highlights both their resilience and the role of favorable rainfall timing rather than precipitation amounts alone. The takeaway for Vista Plains is clear. This is a year when perennial forage is stronger than expected under drier than average precipitation, while annual grasses are almost absent. For managers, this means that grazing strategies should be anchored around the strength of perennials in this allotment, with the understanding that annual grasses anomalies are not reliable indicators when absolute production is so low. The production and precipitation summary table distills the patterns and trends that we've just seen in the maps and charts into numbers. Reading from left to right, the first column shows the year-to-date totals, with annual forbs and grasses at just 2 pounds per acre, perennials at 538.1 pounds per acre, and a combined total of 540.1 pounds per acre. The second column shows what is typical by the same date of August 12 over the last 20 years from 2005 to 2024. We have 3 pounds per acre for annuals, 502.6 pounds per acre for perennials, and a total of 505.7 pounds per acre. The third column converts these numbers into percentages by dividing the year-to-date values for the current year in the first column by the average year-to-date values in the second column. Annual grasses are at only 65.4% of the normal, while perennials are at 107% of normal. Altogether, the total forage production is running about 7% above average. The trend columns add more historical context. This column shows the 20-year trend in total production from January 1st through the date of the report. They show long-term declines in perennial and total production with a loss of 7.8 pounds per acre per year and 7.4 pounds per acre per year respectively. In the last column, we see the mean total year values based on the 2005 to 2024 baseline. These are the long-term full-year averages that help put the current year production into context. Annual grasses typically only add about 3.7 pounds per acre over an entire year, while perennials contribute to the bulk at around 701 pounds per acre. Combined, that means the total forage averages about 704.7 pounds per acre annually. These benchmarks are important. They show what's normal by the year's end, making it easier to see whether the current season is trending above or below the long-term annual expectations. And that precipitation row is key. Year-to-date precipitation is just 9.5 inches compared to a long-term average of 14.4 inches, or about 2/3 of normal. Precipitation averages just over 23 inches a year. In other words, Vista Plains is drier than usual this year, yet perennial grasses are still above average. These numbers give managers a long-term benchmark, helping put the current year's partial totals into perspective. This suggests that either the timing of rainfall was especially favorable or that carryover soil moisture contributed to the above-average production. Just like the previous case study, this report for Bitterbrush Hills allotment was generated on August 12, 2025, so all the data here is displayed until that date. Starting with AFG, we see moderate annual production in parts of the allotment, which is higher than a previous case study, with areas of higher values of production in the central region, which may be tied to local topography, soil types, and precipitation. Moving to PFG, production is broadly stronger, with large swaths of dark green indicating robust perennial growth across much of the unit in the range of 200 to 400 pounds per acre. AFG anomalies are mixed to slightly negative in places, while PFG anomalies are consistently modestly positive, matching what we saw in the production map. Spatially, this tells us that perennials are producing more than average across the land unit. In the production time series heat map, here again the heat maps track AFG and PFG production from 1986 to present. The AFG heat map tells a different story from before. Recent decades show several dark blue or bright green streaks compared to lower production in the previous decades, reflecting recent years of stronger annual grass flushes and higher interannual variability. In 2025, the annuals are tracking near their historical median, but the heat map reminds us that this allotment is prone to big swings in annuals growth depending on factors like precipitation. The PFG heat map shows strong seasonal pulses every summer, and the intensity of production is more or less consistent compared to the previous record, and it does not show an obvious trend. This suggests a multi-decade variation in perennial production during the June to August window, even though this particular year is above the 20-year average. This chart shows the current year production rate in 2025 compared with historical percentiles. Here, the black line traces the total production of annual and perennial forbs and grasses combined across the 2025 growing season. Early in the year, the black line hugs the dotted median line closely, telling us that production was tracking right at normal levels. But as we move into May and June, the line rises into the 60th to 80th percentile band, which means that forage was growing faster than typical for this time of the year. As summer progresses to August, the black line stays elevated above the median, showing that this allotment sustained stronger than normal production through the core of the growing season. This pattern is especially important to highlight because it happened despite below average total precipitation. It shows us that timing of precipitation aligned well with the plant demand allowing perennials to make efficient use of available moisture. These three panels break the totals apart by vegetation type and then link them to precipitation. In the top panel for annual forbs and grasses, the black line for 2025 runs close to and under the mean, but it is over the median, which means that annual grasses are performing about average this year, but still over the 50th percentile. In the middle panel for perennial forbs and grasses, the black line sits well above the mean, median, and 75th percentile, showing that perennials are contributing to the bulk of extra forage production we're seeing in 2025. This finding is critical because it indicates that the system's productivity is being driven by more stable and typically more native perennial species. Finally, in the bottom panel for precipitation, the cumulative total for 2025 is below the historical average for almost the entire year. This contrast underscores a key ecological lesson. Total precipitation does not tell the whole story. In Bitterbrush Hills, the timing and distribution of precipitation events mattered more than the overall amount received. Plants were able to grow efficiently when moisture was available, even if the total was less than normal. Taken together, these right column figures tell a clear story for this allotment. Annuals are holding steady near their long-term averages, but perennials are producing well above normal, driving the system's surplus forage. And while the precipitation totals are lower than the 20-year average, the favorable timing of precipitation events allowed this allotment to sustain above normal productivity through the peak of the growing season. The production and precipitation summary table distills these patterns we saw into clear numbers. Reading from left to right, the first column shows the year-to-date totals. Annual grasses are at about 109.2 pounds per acre, perennials at 277.3 pounds per acre, and a combined total of 386.4 pounds per acre. The second column shows what's typical for the same date over the last 20 years from 2005 to 2024. We have 113.1 pounds per acre for annuals, 230.2 pounds per acre for perennials, and about 343.4 pounds per acre in total. The third column converts these into percentages. So annual grasses are right near average at about 96.5% of the normal, whereas perennials are 120.4% of the normal, and the total production is about 112.5% of the normal. In other words, perennials are clearly outperforming their long-term expectations and are the reason this allotment is running above average overall. The trend columns add historical depth. Perennials show a slight long-term decline of about 2 pounds per acre per year, while total production has a very small positive trend. That variability among functional groups is important because it shows how the balance between annuals and perennials shifts over time. In the last column of the table, we see the mean total year values from 2005 to 2024. These represent the full year averages from January 1st to December 31st, not just what we'd expect by August. In this case for Bitterbrush Hills, annual grasses typically produce about 140.5 pounds per acre over the whole year, perennials at about 290.5 pounds per acre, and a total of 431.1 pounds per acre. Finally, the precipitation row puts all of this into context. Year-to-date rainfall is 5.7 inches compared to the long-term 20-year mean of 7.5 inches, or about 3/4 of the normal. This long-term trend in precipitation is essentially flat, meaning that rainfall has not shifted that much overall. Precipitation averages nearly 12 inches annually. What this tells us is that despite being a drier than average year in this unit, the timing and distribution of rainfall events likely lined up with plant demand, favoring perennial growth. For managers, the takeaway is that 2025 is still a strong perennial year in Bitterbrush Hills. The vegetation production reports provide a wealth of real-time information on vegetation production. While they provide information for the current year, we encourage you to use them alongside the site characterization reports, which provide information on longer-term patterns and trends, and the drought reports, which provide real-time drought information and may help to explain patterns in the production data. Even with all these resources on hand, care should be taken when using satellite-based vegetation datasets, as ultimately they're models of complex ecological systems. These reports will be most useful when used alongside additional evidence like field-based vegetation, ecological sites, photo points, local climate stations, and other locally available datasets. Together, These different sources can help form a more comprehensive picture of a land unit and its history, providing a firmer footing for informing decisions. For more customized analysis of the datasets presented in the vegetation production reports, you can use the Climate Engine app or API, both of which you can learn more about at climateengine.org. The Climate Engine app has been continuously supported by the Bureau of Land Management and NOAA's National Integrated Drought Information System since 2015. It's built on Google Cloud's computing platform called Google Earth Engine, allowing for rapid analysis of decades of climate and satellite-based vegetation datasets. Thank you so much for joining me on this video using the Climate Engine Vegetation Production Reports. This video is accompanied by a tutorial article on the Climate Engine support site at support.climateengine.org, and you can also find additional resources there. If you have any questions about vegetation production reports, please reach out to us using the support site where we'll be happy to assist you. Visit again soon and please subscribe below to see new videos as they come out. Thank you so much again and see you next time.